Okay, so we're working with a dataset that has 10 samples. This is our starting point, the size of our data pool for the machine learning model. This number is crucial for determining the number of iterations in our cross-validation process. Here, we're using scikit-learn's LeavePOut function. That tells us it's working with 10 total samples, as we already know. That means that in each iteration of the cross-validation, 2 samples will be left out as the test set. Let's see how this impacts the number of folds, iterations. The main challenge is to figure out how many folds LeavePOut will generate with these specific settings. We are specifically examining the number of training and testing sets generated. We'll be using a combination formula to solve this problem. We're using a specific cross-validation technique to evaluate a model. That technique is LeavePOut, which is part of the scikit-learn library. This method repeatedly splits your dataset, omitting some samples at each step to help gauge how well your model generalizes. This option suggests that the number of folds is less than 45. We need to calculate the actual number of folds to verify if this statement is true or not. This directly relates to the combination formula and our calculations from it. This option describes the composition of each fold. We'll investigate to see if each fold created from the cross-validation contains 8 samples for training and 2 samples for testing. This relates directly to how LeavePOut works. It leaves out P samples for testing, leaving the remainder for training. This statement links the number of folds to the number of ways you can choose 2 samples out of 10 without replacement. This is a combinatorial problem. It implies that the number of folds is directly related to this combinatorial calculation. This option gives a specific number of folds, 45. We need to confirm if this aligns with the calculation using the combination formula and the provided parameters, n and p. This refers to a scikit-learn function used for model evaluation. It's a type of cross-validation where p samples are left out for testing in each iteration, ensuring that every sample gets a chance to be in the test set. The machine learning model will be evaluated using a dataset consisting of 10 data points. This is the n value in the LeavePOut function. This specifies the parameters for the LeavePOut cross-validation function. N equals 10 indicates 10 total samples, and p equals 2 means 2 samples are left out as a test set in each iteration. We need to determine how many different ways we can select a test set of size 2 from 10 samples. This is equivalent to calculating the number of iterations or folds in the cross-validation process. This uses the combination formula. In simple terms, it calculates the number of ways to choose 2 items out of 10, without regard to order. The formula is explained as 10 factorial, divided by the product of 2 factorial, and 8 factorial. It simplifies to 45, which represents the total number of folds or iterations. The calculation shows that LeavePOut 2 will produce 45 different training and testing splits. Each iteration in the LeavePOut process will create a specific training and testing dataset. In each iteration, 8 out of 10 samples are used to train the model. 10 total samples, 2 test samples equals 8 training samples. In each iteration, 2 samples are held out for testing the model's performance. This line specifies the parameters for scikit-learn's LeavePOut cross-validation. N equals 10 means we have a dataset with 10 samples. P equals 2 indicates that in each iteration, 2 samples will be left out for testing. It's like saying, let's take 2 samples out, then train on what's left, and test on these 2. Think of it as a systematic way to divide your data for model training and evaluation, ensuring you utilize all parts of your data. This part sets up the calculation to determine how many different ways we can split the data following the LeavePOut strategy with 10 samples and 2 left-out samples in each split. This is crucial because the number of folds directly impacts the training and testing process. This is the result of the calculation. It signifies that the LeavePOut method will create 45 different training and testing splits of our data. Each split is unique, which is great for robust model evaluation. In each of the 45 iterations or folds, 8 samples will be used to train the machine learning model. Because there are 10 samples and 2 are held out for testing, 10 minus 2 equals 8 remain for training. Think of it as giving the model 8 examples to learn from before testing its knowledge. In each iteration, 2 samples are kept separate to test the model's performance. This is the subset of the data the model hasn't seen during training. It's a crucial part of evaluating how well the model generalizes to unseen data. This is the mathematical formula used to calculate the number of folds, 45. It's a combinatorial calculation, 10 factorial divided by the product of 2 factorial and 8 factorial. This formula essentially calculates all the possible combinations to choose 2 samples out of 10 without replacement or order mattering. This is the core of how LeavePOut determines the number of folds. It's like counting the number of ways to pick 2 friends out of a group of 10, where the order doesn't matter. This describes the cross-validation technique being used. LeavePOut is a method where P, in this case, 2 data points are left out for testing in each iteration, while the rest are used for training. N represents the total number of data points, 10. It is a way to robustly evaluate a model's performance. This tells us the size of the dataset. We have a total of 10 data points to work with for training and testing our machine learning model. This is one possible answer to the question of how many training testing sets are created using the LeavePOut method with the given parameters. A fold represents one iteration of training and testing the model. This is another possible answer that suggests that the number of folds is less than 45. Let's see if this is true. This describes the composition of each fold. In every iteration, 8 samples are used for training the model, and the remaining 2 samples are held out for testing its performance. This expresses the number of folds in terms of combinatorics. It's asking, how many ways can you choose 2 samples out of 10, without considering the order? This is equivalent to the number of folds generated by LeavePOut. This is the mathematical formula for calculating combinations. N is the total number of items. P is the number of items chosen. The symbol represents the factorial, e.g., 5 equals 5 asterisk 4 asterisk 3 asterisk 2 asterisk 1. It determines how many ways we can select P items from N items. This shows the calculation of the number of folds using the combination formula with N equals 10 and P equals 2. The result, 45, indicates that there will be 45 iterations in the cross-validation process. This is the final answer to the quiz question. The total number of folds generated by LeavePOut, N equals 10, P equals 2, is 45. The problem involves a dataset with 10 samples. This is the total number of data points used for model training and testing in the scikit-learn's LeavePOut cross-validation. The problem involves a dataset with 10 samples. This is the total number of data points used for model training and testing in the scikit-learn's LeavePOut cross-validation. In each iteration of the LeavePOut cross-validation, P represents the number of samples that are excluded from the training set and used as the test set. In this specific problem, P equals 2, meaning 2 samples are held out as a test set in every iteration. In each iteration of the LeavePOut cross-validation, P represents the number of samples that are excluded from the training set and used as the test set. In this specific problem, P equals 2, meaning 2 samples are held out as a test set in every iteration. We need to determine how many iterations or folds the LeavePOut cross-validation will produce with 10 samples and 2 samples left out in each iteration. We need to determine how many iterations or folds the LeavePOut cross-validation will produce with 10 samples and 2 samples left out in each iteration. This formula calculates the number of combinations of choosing P items from a set of N items without replacement or considering order. It's used here to find the number of folds. N means N factorial, N, N1, N2, asterisk. Asterisk 1, for example 3, equals 3 asterisk 2 times 1 equals 6. This formula calculates the number of combinations of choosing P items from a set of N items without replacement or considering order. It's used here to find the number of folds. N means n factorial. N, n1, n2, asterisk. Asterisk 1. For example 3, equals 3 asterisk 2 times 1 equals 6. Applying the formula with n equals 10 and p equals 2 gives us 10 asterisk 9 asterisk 8 asterisk 7 asterisk 6 asterisk 5 asterisk 4 asterisk 3 asterisk 2 asterisk 1. 2 asterisk 1. 8 asterisk 7 asterisk 6 asterisk 5 asterisk 4 asterisk 3 asterisk 2 asterisk 1 equals 45. This calculation shows there will be 45 different ways to select 2 samples out of 10. Applying the formula with n equals 10 and p equals 2 gives us 10 asterisk 9 asterisk 8 asterisk 7 asterisk 6 asterisk 5 asterisk 4 asterisk 3 asterisk 2 asterisk 1. 2 asterisk 1. 8 asterisk 7 asterisk 6 asterisk 5 asterisk 4 asterisk 3 asterisk 2 asterisk 1 equals 45. This calculation shows there will be 45 different ways to select 2 samples out of 10. The result of the calculation indicates that the LeavePOut cross-validation will generate 45 folds, iterations. The result of the calculation indicates that the LeavePOut cross-validation will generate 45 folds, iterations. In each fold, 8 samples, 10 total samples 2 test samples, will be used to train the machine learning model. In each fold, 8 samples, 10 total samples 2 test samples, will be used to train the machine learning model. In each fold, 2 samples are reserved to evaluate the model's performance, test set. In each fold, 2 samples are reserved to evaluate the model's performance, test set. Hey Vamsi. This line sets up our experiment. We're using a technique called LeavePOut cross-validation from scikit-learn, a popular Python library for machine learning. Specifically, we have 10 data points. And in each round of testing, we're leaving out 2 of them. Think of it like this. Imagine you have 10 cards, and you're trying to predict the values on some of them. Each time, you put aside 2 cards, your testing set, and use the remaining 8 to train your prediction model. This is the central question, Vamsi. A fold in cross-validation is just one iteration of the training and testing process. We want to know how many times we'll go through this 8 train, 2 test cycle with our 10 data points. This is one possible answer, Vamsi. It claims there will be 45 folds. We need to check if this is correct by working through the formula. Here's another option. It suggests there'll be asterisk fewer than 45 folds. Whether this is correct depends on our calculation, which should tell us exactly how many folds there are. This describes what each fold looks like. It says in every fold, each iteration, the model will be trained on 8 samples and tested on 2. This makes sense if we're leaving out 2 samples in each step. This is a clever way of looking at the problem. It's saying the number of folds is the same as the number of ways to pick 2 samples out of 10, without considering the order. This is a combinatorial problem, and we can solve it with the combinations formula to confirm if this is true.